In this video lesson, we are going to study the oxidation of primary and secondary alcohols. Precisely, we will cover the oxidation of primary alcohol using suitable oxidizing agent. We will also cover the oxidation of secondary alcohol using suitable oxidizing agent. We will also observe or take note of the observation of the reactions in the laboratory. And lastly, we will answer a few related exam past questions. Before we start, what is oxidation in organic reaction? What is oxidation in organic reaction? Oxidation reaction in organic reaction is the simultaneous addition of oxygen atom into a molecule and subsequent removal with hydrogen. In organic reaction, as I said, oxidation is addition of oxygen atom into a molecule and the removal with hydrogen. In this oxidation reaction of primary and secondary alcohol, we will be using, there are some symbols like a symbol like this, a square bracket, oxygen in square bracket. We will use symbols like this. We will be using symbols like that. Some of these symbols will, this symbol will signify or signifies that oxygen is added from an oxidizing agent. This symbol, as you see like this, signifies that the oxygen added is from an oxidizing agent. And it is represented like in this form, oxygen in a square bracket. So now, for this reaction to occur, as you see here, for this reaction to occur, the reagent for this oxidation of primary and secondary alcohol, suitable oxidizing agent here will be acidified potassium dichromate 6, or acidified potassium manganate 7 solution. Obviously, you will have to heat this under reflux. Let's start with primary oxidation of primary alcohol. Using primary alcohol, and our example is primary alcohol. For instance, ethanol. This is ethanol. What you will see here will be, we have this Here we will have excess potassium dichromate. We can have excess potassium dichromate, CrO2. Or we will have excess of any of these can work. Excess manganate, potassium manganate 7. And what you have will be is ethanol, and this is what we call ethanol. Here, what happens here is there is oxidation here. There is oxidation there. You see here, as I've just illustrated it, this is a molecule of ethanol. This is a molecule of ethanol in excess. Any of the oxidizing agent could be excess potassium dichromate, excess potassium, excess acidified potassium dichromate, or excess acidified potassium manganate solution. As I said, oxidation is the addition of oxygen to a molecule and subsequent removal with hydrogen. And subsequent removal with hydrogen. In this reaction, you will see that under this condition, a molecule of water is being removed and the ethanol is being produced. That is why I said primary alcohols are heated under reflux with a good oxidizing agent like excess acidified potassium dichromate or excess acidified potassium manganate 7. When it is heated under reflux with any of these oxidizing agent, if the alcohol used is in excess, the product formed is distilled immediately. If this product, which is ethanol, formed, it must be distilled immediately. But if it is not distilled immediately, this product is further oxidized to the corresponding carboxylic acid. So the condition here is that when ethanol is heated under reflux with excess acidified potassium dichromate 6 or excess acidified potassium manganate 7, The product form, which is ethanol, is distilled immediately. If not, the ethanol is further oxidized to the corresponding carboxylic acid, which is ethanoic acid. Let's go further to see what happens. Step 2. If not distilled off immediately, further oxidation occurs. If not distilled off immediately, the ethanol is further oxidized to carboxylic acid, that is ethanoic acid. And this is, it can be represented like this. The ethanol I said addition of oxygen. That is the oxidation that is taking place there. Here under excess potassium dichromate 6 acidified O excess potassium manganate potassium manganate 7 excess acidified potassium manganate 7. So under this condition, we will have ethanol and ethanoic acid. Ethanoic acid. So now, step number 2. If the ethanol that is formed is not distilled off immediately, the ethanol is further oxidized to ethanoic acid. The reagent, as we said, excess acidified potassium dichromate 6 or excess acidified potassium manganate 7. So that is the condition. Yeah, this is step 1. This is step 1. So step one, the step one, the primary alcohol is heated under reflux with a good oxidizing agent. If the alcohol is in excess, the product form is distilled immediately. So the ethanol, if you want to get the ethanol, it must be distilled off immediately. Else, further oxidation will take place. Now, oxidation of secondary alcohols. Oxidation of secondary alcohols. For secondary alcohol, you should know that for secondary alcohol, we will use the same reagent. In secondary alcohol, we will use the same reagent. Or like in this case, let me use this. Here we will be using here we will be using propan-2-ol as an example for this. Propan-2-ol, we have CH3, that's propan-2-ol. Will undergo oxidation, and what will be formed there will be so this is propan-2-ol. This is propanone, or what we call acetone, or systematic naming we can call a propan-2-one, and water. We have this here. Addition of oxygen to a molecule and removal with hydrogen. We have added an oxygen here. At the same time, we are now going to remove it with hydrogen. That is what happens in organic reactions, oxidation in organic reactions. You can either use this, or you can use this. You can either use acidified potassium manganate 7, or you can use acidified, or you can use acidified potassium dichromate 6. You can either use this or this. Then you have to heat under reflux. Heat under reflux. You heat under reflux. So with this, you see what should come to your brain now is secondary alcohols. For example, propan-2-ol are oxidized to what? To ketone. This is a ketone. Secondary alcohols are oxidized to ketone, and this is a ketone. Propanone or acetone or systematic name, which is propan-2-ol, is a ketone. And what is left is a molecule of water that is also removed. You see, it can be indicated by this oxygen here attaching itself to this. So, once more, primary alcohols are oxidized to what? Primary alcohols are oxidized to carboxylic acid. But if you want to obtain an aldehyde, immediately the reaction mixture is heated under reflux. The product form should be distilled immediately. The aldehyde form should be distilled immediately. As soon as the aldehyde is formed, it should be removed immediately. If allowed to stay in the reaction container for a longer time, what happens is that there is further oxidation. There is further oxidation. If not distilled off immediately, ethanol is further oxidized to ethanoic acid. So primary alcohol are oxidized first to aldehydes. If the aldehyde is not removed, it is further oxidized to what? To carboxylic acid. And this is what happens here with ethanol. Secondly, secondary alcohols. Secondary alcohols using suitable oxidizing agent such as acidified potassium dichromate 6 solution or acidified potassium manganate 7 solution. When heated under reflux, the final product of the secondary alcohol would be a ketone. And in this case, that we are using propan-2-ol as our secondary alcohol, we've got propanone or propan-2-ol and a molecule of water. With tertiary alcohols, such as 2-methyl propan-2-ol, secondary alcohols such as 2-methyl propan-2-ol, we will have a molecule like this. Under all the conditions, using acidified potassium dichromate or acidified potassium manganate 7 solution, there will be no reaction. No reaction occurs. There will be no reaction. No reaction is seen. Why I say there's no reaction? Tertiary alcohol will not be oxidized because there is no hydrogen here. No hydrogen attached to the carbon atom, this central carbon atom having the functional group. There's no hydrogen, only the alkyl groups. All the hydrogen here have been substituted by the alkyl groups. So in that case, there's no hydrogen here that will be used to remove. So we can now say no hydrogen, no hydrogen atom attached to this carbon for the oxygen to remove. No hydrogen atom attached to this carbon. To this carbon for the oxygen. For the oxygen to remove. Remember I said if we add an oxygen here, oxidation is addition of oxygen. Since there's no hydrogen attached here like in the previous cases, there's no hydrogen attached to this carbon atom having the functional group. There's no hydrogen attached here. All are alkyl groups. For that reason, oxidation will not occur. There will be no reaction because there is no hydrogen attached to this carbon for oxygen to remove. So no reaction occurs here. No reaction will occur here. So in that case, like in this case, these are hydrogen. In the case of secondary alcohol, these are hydrogen atoms that this oxygen that has been added will remove. In primary alcohol, the same thing happened. This is oxygen here, these are hydrogens here that the oxygen was used in removing to form the molecule of water. But in the case of tertiary alcohol, there is no hydrogen here. And in that case, there is no oxidation. And consequently, there is no reaction. So we can conclude that only primary and secondary alcohol will undergo oxidation using suitable oxidizing agent such as acidified potassium dichromate 6 or acidified potassium manganate 7. Excuse me. Tertiary alcohol will not undergo oxidation because no hydrogen is attached to the central carbon for oxygen to remove. Finally, we will have to solve a past examination question paper here. This is part and related to our lesson. You have the question paper here. You have the question paper here. Before we go ahead, once more, in our observation, remember that if acidified potassium dichromate is used as an oxidizing agent, the color change will be from orange to green. If acidified potassium dichromate was used as our oxidizing agent, when there is oxidation like in primary alcohol, the color will change. The color of the solution will change from orange to green. signifying that the orange dichromate precipitate is reduced from +6 to chromium 3 plus ion. In the same way, if you used if an oxidizing a suitable oxidizing agent such as acidified potassium manganate 7 was used, if acidified potassium manganate 7 was used as our oxidizing agent, when oxidation occurs, for example, in this very case again, when oxidation occurs, what happens is that the color of the solution will change from purple to colorless. The purple manganate, precipitate ion will be reduced to colorless manganate 2. So for manganate, you were using acidified potassium manganate 7 ion. What you will do will be that the purple color in the test tube will change to colorless, signifying that the manganate 7 precipitate have been reduced to colorless manganate 2 ions. Okay, let's proceed to our question paper. And our question paper is part of question number 5. A reaction sequence based on proper 1 ol is shown below. This is a reaction sequence. This is a reaction. We have propan. There is proper 1 ol. Proper 1 ol in reaction 1 is oxidized directly to carboxylic acid. Proper 1 ol in reaction 4 gives what? It gives a halogenoalkane, that is it gives bromopropane. Proper 1 ol in reaction 3 gave us about what we call an alkene. It has undergone what we call hydration. There is hydration that has taken place here. I mean a dehydration, sorry. There is dehydration that has occurred in reaction 3 to give us an alkene. In our previous studies, we did a dehydration of alcohol. So dehydration of alcohol will lead to alkene. In reaction 4, there is halogenation of alcohol leading to halogenoalkane. There is bromopropane. Proper 1 ol in reaction 2 gave us propanol, gave us propanol. And this propanol is as a result of it is not complete oxidation, it is oxidation of propan 1 ol to what? To propanol. The oxidation is not complete. Now, this is again, there is a nucleophilic addition here to form the cyanide or nitrile, hydroxy nitrile. Let's go to our question. A, reaction 1 and 2 can both be carried out using the same reagent. Of course, we have just done oxidation of primary alcohol there. Let me go back again. Reaction of oxidation of primary alcohol. In this case, you see the reagents: acidified potassium manganate 7 solution, or acidified potassium dichromate 6 solution. We oxidized. We had for secondary alcohol we had a ketone. For primary alcohol, the same reagent we had aldehyde, that is ethanol. Ethanol was oxidized to ethanol. Then further oxidation occurred if the ethanol was not distilled off. Further oxidation occurred where ethanol was further oxidized to the corresponding carboxylic acid, which is ethanoic acid. Now the same question is here for you to answer. You are in the examination room. You are told, identify suitable reagents for reaction 1 and reaction 2. This is an oxidizing agent. This is reaction 1. The suitable reagent there is an oxidizing agent. And which is the oxidizing agent? We have two oxidizing agents. You could either use excess. You could either use excess acidified potassium dichromate 6. Excess acidified potassium dichromate dichromate 6 solution. Or you could use excess. Here this will be CR2. It could be used. It is CR2 O7 or you could use excess acidified potassium manganate 7. Excess acidified potassium manganate manganate 7 solution, which can be written here as your Mn those are the suitable reagent you can use. Excess acidified potassium dichromate 6 solution, or you can use excess acidified potassium manganate 7 solution. These are good oxidizing agents. Now, state and explain the reaction. State and explain how the reaction should be carried out to ensure that reaction 2 rather than reaction 1. Which is reaction 2? Reaction 2 is oxidation only to the aldehyde. Oxidation of propan 1 or to what? To propanol. So state and explain how the reaction should be carried out to ensure that we do the oxidation and get but propanol. We don't go to acid. In order to get just the aldehyde, in this case propanol, what will be the condition? Stating the condition will be that if you are in the examination room, what you are expected is that in this, you have to heat excess propan 1 or under reflux with excess potassium dichromate 6 or excess potassium manganate 7 solution. You can say here that your heat under reflux, heat reaction mixture under reflux with heat reaction mixture under reflux heat reaction mixture under reflux heat reaction mixture under reflux with what? With excess O4. Yeah, you heat the reaction mixture under reflux with excess acidified potassium manganate 7 or excess acidified potassium dichromate 6. Then, that is 1. 2. The product formed. Now, you are now answering the second section of it. Explain how the reaction should be carried out so that only 2 rather than 1. You now say the product formed. When propanol is formed, it should be distilled immediately. When propanol is formed, it should be distilled immediately. Because if allowed for some time, it will undergo further oxidation to form propanoic acid. We can say distill propanol immediately it is formed. Distill propanol immediately as soon as it is formed. Distill propanol as soon as it is formed because or else distill propanol as soon as it is formed, else it will undergo further oxidation. It will undergo further oxidation to what? To propanoic acid. That is it. State and explain how. Now, heat reaction mixture under reflux with excess of the oxidizing agent. 2. Distill the propanol as soon as it is formed. As soon as it is formed. As soon as it is formed. Else, it would undergo further oxidation to propanoic acid. That is just all. Be part of it. Identify the necessary reagents and conditions for each reaction 3 and 4. Which are the reaction 3 and 4? I said reaction 3. Reaction 3 will undergo dehydration. Reaction 3 will undergo dehydration. Using what? Using excess concentrated sulfuric acid. So identify necessary reagent and condition. So the reagent here, reagent will be what? Reagent is excess concentrated sulfuric acid. Then what will be the condition? The condition is heating the reaction mixture at a temperature of about 180 degrees. heating reaction mixture to about 180 degrees Celsius. So this is reaction 3 is a dehydration reaction of alcohol. So we have to heat the alcohol with excess concentrated sulfuric acid to a temperature of about 180 degrees Celsius. Then reaction 4 will involve what? Reaction 4 will involve halogenation of alcohol to form halogenoalkane. Now, what will be the reagent? Well, there are many sources of the halogen. So the reagent in this case, so it is we can produce a halogenoalkane by using hydrogen halide. So it is a bromine here. We can produce it from a hydrogen halide, and the hydrogen halide. Now, in that case, we can use hydrogen bromide as our reagent. Hydrogen bromide can be our reagent. Hydrogen bromide. We can also use it. You can also take it from maybe some phosphorus halide using phosphorus pentabromide, phosphorus tribromide, other things like that. But in this case, we have decided to use it as hydrogen bromide as our reagent. Then secondly, what are the conditions? Now, hydrogen bromide is then reacted with propan-1-ol to give bromopropane. Hydrogen bromide is reacted. HBRO is reacted with propan-1-ol to form bromopropane. So learners, all these synthetic routes, you are supposed to know them very well. Be used to these synthetic routes. You should know what is happening in each of the routes: reaction 1, reaction 2, reaction 3, reaction 4, and reaction 5. But remember, you could have been given reaction 5. This reaction for the nucleophilic addition of cyanide into this carbon, so it's telling you that an extra carbon atom has been added here. And this one here result in a chiral compound. This compound has four different groups attached to the central carbon. And for that reason, it can result in optical isomerism. So you are reminded to study such synthetic routes so that in subsequent exams, if you happen to find such questions in your exam, you should know how you can interpret them and answer them. Once more, suitable oxidizing agent, we were talking of excess acidified potassium dichromate 6 or excess acidified potassium manganate 7 solution. You must have to heat the reaction mixture under reflux with excess of this oxidizing agent. To obtain the aldehyde, you have to distill the aldehyde as soon as it is formed, without which it will undergo further oxidation to propanoic acid. Then dehydration of alcohol will result in alkenes. Our reagent, we said it was excess concentrated sulfuric acid. that you must heat the reaction to a temperature of about 180 degrees Celsius. Halogenation of alcohol, we call it a nucleophilic substitution of the OH group to give a halogenoalkane. Here we were using hydrogen bromide as our reagent, and the condition will be to react the hydrogen bromide with propan or to have our bromopropane. Thank you. Once more, if you haven't subscribed to our channel, please subscribe and hit the notification bell. Thank you for watching.